Hello everyone and welcome to Aviatrix Deep Dive with Saad. In this session I'll be discussing about the hybrid connectivity for GCP. So you have two different options when you are connecting your on-prem to the GCP environment. Private circuits and then the public circuits. In the private circuits there are again a number of options like without end-to-end encryption, with end-to-end encryption. Encryption could be the standard encryption or maybe high performance encryption. Similarly, in the public circuits, there are two options: standard end-to-end encryption or high performance end-to-end encryption. All right, so let's talk about all those one by one. First, I'm going to discuss about the private circuits. So I'm going to All right, so the first architecture is without any kind of end-to-end encryption when customer either does not has the IPsec capable on-prem devices or they don't want to manage any kind of an IPsec in their on-prem environment. So what option do they have? GCP announced the NCC a few months ago, and then Aviatrix has the full integration with the GCP NCC, which is Network Connectivity Center. Let's take a look at what architecture is going to look like. So the first option or with the private circuit is going to be with the NCC. We do have Aviatrix spoke and transit architecture, Aviatrix spoke gateways, and then Aviatrix transit gateways in transit VPC. You attach spoke gateways with the transit gateways. As I explained previously, I'm showing only one connection between the spoke gateways and a transit connection. In reality, there are about 4 connections from each spoke VPCs. So they are all active mesh connections. Now, you need another VPC over here, which either you wanted to call it BGP or LAN VPC or maybe your NCC VPC. Here, you are going to have your cloud routers and then the other interfaces of your transit gateways. Let's draw an on-prem environment on the right-hand side. Let's say this is your WAN router. Your WAN router is going to be connected to your cloud using a private circuit. In this scenario, since we are talking about the GCP, this is your cloud interconnect. Here you are going to use cloud router, and if we are using dual, like redundant cloud interconnects, then let's say we have another one and we are going to use another cloud router here too. Okay. All right, so let's draw this a little bit differently. All right, so if I'm going to say this is zone 1, that's zone 2, then I'm going to draw another cloud router in a different zone. Okay. Now, these are going to be the interfaces for my transit gateway, right? This is the transit. Let's say this is the primary, this is the HA gateway. All right. And then we are going to have one more interface for this guy over here as well. Okay. And then we can draw like that. Okay, so these are basically all the interfaces. What we are going to do in this scenario, we are going to have a connectivity between the cloud router and then the interfaces of your transit gateway and then the HA gateway like that. By the way, this connectivity is without any kind of tunneling protocol. This is pure vanilla BGP running between them, and Aviatrix calls it BGP or LAN. So there is no performance limitations, nothing. Whatever the cloud constructs provides you, you are going to get that kind of throughput. Same thing in this scenario as well. You will be connecting your cloud router with the interfaces of the transit gateways, the primary and then the HA gateway. And again, there's a lot more redundancy available. Since this entire architecture is based on the NCC that we are discussing right now, then NCC has a little bit of different rules. NCC has its own concept of spokes. So let's draw those out over here as well. First, you have to create the NCC hub, right? And then let's say you have already created the NCC hub, and now we need some spokes. So let's say you wanted to call the transit, and by the way, these are the Aviatrix transit gateway. Could be your ETH0, and then, or maybe just call it ETH1 for now, transit gateway, and then it's going to be your transit gateway, again ETH2. This is your transit HA, ETH1, and one more over here, which is transit HA, ETH2. So they're all part of your NCC and becomes the NCC spokes. So the spokes has to be attached to the NCC hub. Now once you have that and you create the CR, then you will be able to have the BGP over LAN in this scenario, right? So if you want to call out this as a transit VPC, this becomes your NCC VPC, or you wanted to call it the BGP over LAN. So BGP over LAN is a feature of Aviatrix, which we will discuss in detail in the upcoming sessions too. So what is going to happen overall routing, right? Here, your WAN routers are going to advertise your RFC 1918, non-RFC 1918 routes over to the cloud router. Cloud router has those routes, but without the NCC cloud router, you cannot have the BGP adjacency with any devices, any third-party devices. In this scenario, we are talking about the Aviatrix gateway. But since we are utilizing, Aviatrix has the integration with the NCC, now you can run the BGP between these two devices, and then the Aviatrix transit gateways are going to receive all the on-prem routes over here. Aviatrix transit gateways receives the BGP routes, and then Aviatrix controller are going to program the routes in the spoke gateways using the SD routing, which is software-defined routing. And then if these are the non-RFC 1918 routes too, Aviatrix controller is going to program the VPC routing table over here with non-RFC 1918 routes too. RFC 1918 routes, summary routes, has already been programmed in these VPCs, which are the spoke VPCs, at the time when you attach the spoke gateways to the transit gateway, so you really don't need to do it again. So this is about the NCC. Now let's talk about the next option, which is the standard encryption. At the transit level, we have the cloud router to the transit VPC, and then the on-prem is connected again using the private circuit, or here the cloud interconnect, and then the WAN router attached to the cloud router. What this WAN router is going to do is going to advertise its connected interface to the cloud router, and cloud router is going to advertise all the subnets of the transit VPCs to the WAN router. At this point, the WAN router has the reachability of the private IP of the transit gateways because the cloud router has already advertised all the subnets of the transit VPC. Transit gateways also has reachability to the WAN router through the CR and the WAN router BGP route propagations. So how this overlay is going to build? From the controller, you are going to build the IPsec connectivity back to the on-prem router. These on-prem router could be 1 or it could be 2. It's totally dependent on what customer wants. Typically, there are always 2 because of the redundancy purposes. And now I'm going to draw another one over here too. Okay. And then you are going to build the redundant tunnels over here too. So these are going to be the IPsec tunnels. And BGP is running over here. You can send all your routes to the transit gateway. At this level, when transit gateway receives a route, the controller is going to now program the spoke with the software-defined routes, and if there are non-RFC 1919 routes exactly the same way as the NCC, the controller is going to program the VPC routing table also. Here in this scenario, your throughput is going to be limited over here in this architecture. You can go up to 5 gigs. If you are looking for more than that, then you can run multiple IPsec connections back to the transit gateway. Similarly, if you have a use case where you wanted to segment the traffic, you can bring these connections into different segments by using Aviatrix multi-cloud network segmentation feature. All right, so let's take a look at another architecture, which is the high-performance encryption. I'm going to reuse this drawing, and instead of building the connections over here with this with the WAN router, what we are going to do, we are going to deploy Aviatrix software at the data center or on-prem. So this is going to be Aviatrix Edge, and instead of building the IPsec tunnels with the WAN router, what you are going to do, you are going to actually building these connectivity or tunnels over here to the edge. The advantage of this architecture is there is no limitation on the performance. It can go 10 gig plus depending on what size of the cloud interconnect you use, and then all these tunnels are self-managed, so you really don't have to manage anything. Depending on the edge platform, what you can do, you can, using the BGP, you can advertise the routes to the transit, and transit is going to again propagates the routes into the spoke gateways and the VPCs using the Aviatrix controller. A type of edge which we are using, either edge version 1 or version 2, we can either use the BGP over here, or we can use the SD routing in this architecture as well. All right, so let's talk about the next option, and that option is over the internet or public circuits. All right, so when we're talking about the public circuit, it basically means over the internet. The architecture is going to be pretty much the same from Aviatrix perspective. It's going to be spoke and then a transit. So you have spoke and spoke VPCs, and then you have transit gateways in transit VPC. Again, you have attach your spoke gateways to the transit gateway. From your on-prem world, you are going to have a connectivity using the internet. And this is a CR, a cloud router. Yeah. Now, this entire architecture, the connectivity from on-prem to the cloud is going to be on the public IPs. So you are going to build the connection from your on-prem world to the transit gateways using the public IPs over here. And when you are going to build the IPsec from the cloud side, you have to log into the Aviatrix controller and then create the connection back to the on-prem. It's going to be, again, IPsec, and BGP will be running all the way up to your transit. This architecture is end-to-end encrypted, and then again, it's standard encryption. All right, so what about the high-performance encryption over the internet? What I'm going to do pretty much the same thing. I'm going to draw Aviatrix edge devices, and then instead of terminating the IPsec on the WAN router, I'm going to terminate that on the Aviatrix edge. Similar to the one that we are showing over here on the side, which is with using the cloud interconnect, but this time the medium is internet, so the performance is going to depend on the internet side. All these tunnels, as I explained previously as well, these are all self-managed, and then throughput totally depends on the internet speed. All right, thank you very much for watching. In the next session, I'll be discussing the hybrid cloud connectivity for OCI environment.